All right, good morning. I had the wrong book. Happy Monday.
Yeah.
Let's see. This doesn't really pertain to you too much, but I'm just letting you know that I've been getting more pre-calculus exams because they're doing a review right now. And I have people saying that the test isn't there and this and that and this and that and this and that. So I'm just letting you know you are responsible for taking the exam when I give exams. If you don't, you will get a 0, and you will have to meet with me, possibly with your parent or guardian, to explain exactly what's going on. So I don't believe in students having preferential treatment over my other students. So when you take an exam late, you're getting preferential treatment. You have more time to study, and basically it's not fair, and I don't like it. So like I said, it really doesn't pertain to you too much, but you are expected to take exam when it's given. Also, we're going to soon be in the month of October. And if there's anything going on with you, if you're missing an exam or something, you need to get it taken care of as soon as possible, because in December, I'm not going to do anything with missing exams or anything like that. So you're going to have to schedule an appointment with me. I am not going to I've already sent millions of emails out and trying to get some of you to respond to me, but you're going to have to, if you want to pass the class, you're going to have to set up a meeting with me, and we're going to have a plan as soon as possible about anything that's going on as far as you missing anything. All right. Well, I have not finished lesson 3.1, but I am going to finish it today. And it was supposed to be due, I think, on, I'm not sure, but I changed. So I have this due now on Thursday night, and I just posted a review for 3.1 due on Friday night. So obviously it's one day, because do it in one day. So it does look like the exam. I am going to only test you on 3.1. It's not going to be a bunch of different, sections this time, lessons. It's only going to be 3. And the exam for 3.1 is going to be Tuesday morning at 8. So let me finish it. Last time we met, I was talking about complex numbers. And just to let you know, without being real technical, if a number looks like a real number, we're not going to call it complex, we're just going to call it real. If a number has an I in it, we're not going to call it complex imaginary, complex pure imaginary. We're just going to call it imaginary if it has an I in it. Okay? So remember, anytime you have a negative under a square root, now this isn't true for cube roots or radicals with odd indices, but whenever you have a negative under a square root, an I comes out. And I have a negative under a square root. We say that square root of -1 is equal to I, so an I comes outside the radical. I also showed you a couple of common quadratic models. One was a distance model and one was a height model. And you can expect to see those, 1 or 2 of those on the exam. And I think I ended there after, well, I started talking about squaring imaginary numbers. So, and I also explained that I squared is equal to -1. All right, so now we're at the point where we're going to solve a quadratic, and we're going to end up with imaginary solutions. So I may have done this problem in class, but here we are solving with imaginary solutions. Just say solve, and you just think it's like any other solving quadratic problem. So it's like, okay, we're solving this, and it says to solve by square roots. And remember, in order to solve with square roots, you can't have an x. So I think we're good. And remember, the steps are isolate the square, take the square root of both sides. Don't forget plus or minus. So x is equal to, you have to do a prime factorization. Now, a couple things. First of all, you're going to do a prime factorization on 12, but that's -1 times 12, and the square root of -1 is I. So that's good enough just to do that. So you have a negative under square root, bring an I out. So 12 is 4 times 3. So x is equal to plus or minus 2 radical 3I. So your two solutions are -2 radical 3I and positive 2 radical 3I. Remember what I said, the imaginaries come in pairs. They're actually called complex conjugates. And the other thing that I want you to know is that in calculus, Mr. Johnston allows you to write the answers like this, 2I radical 3. And the reason why is because I don't want the I to look like it's under the radical, because it's not. Now, the reason why I don't want you to write them like that is because I always want your answers in this class written in the standard form of a complex number, a plus bi. So I want it written like this. Mr. Johnston doesn't care if you write it like that. We're going to write it like that in this class. All right, let's do another problem. 4x squared plus 11 equals 6. So using square roots, we want to isolate the square. So we get 4x squared equals a -5. Divide both sides by 4. X squared is equal to -5/4. Take the square root of both sides. Make sure you bring that radical all the way down. So x is equal to plus or minus. Can't have a fraction under a radical. So first of all, you see the negative under there? So I'm going to bring the I out, and I'm going to split this up to square root of 5 over square root of 4. Can't have a radical in the denominator. So your final answer would be square root of 5 over 2I. So remember, the imaginaries come in pairs. They're complex conjugates.
Can you move your camera down a little bit, please? Thank you. Okay.
One is negative radical 5 over 2I. And the other one is radical 5 over 2I. So you're solving them just like we would with any, we square root on anything, except when you get imaginary roots or solutions. These are problems where you're going to end up with a -1 under the radical. Can't leave the negative under the radical. So you got to bring out the I. Okay. Are there any questions? All right, I do want to look at a couple problems in, so please look at your assignment. Take a look at page 120. So on page 120, we did a math wizard team the other day on this. You had to solve a problem 3 different ways. You had to solve it by using the graphical approach and getting the x coordinates at the points of intersection. You had to solve it using factoring, and you had to solve it by square roots. Turn the page. Number 3, you know how to solve quadratics using square roots. The steps are: you isolate the square, you take the square root of both sides, and don't forget plus or minus. Number 7 and 8 are those 2 formulas that I gave you for working, real life applications with distance and height. I do want to set up number 9 and 10 for you. This is also on the review, and I don't know if I'm going to put this on the exam or not yet. So number 9, and I'm on page 122. They give you a rectangle and they label it X and 3X. So the width is X, the length is 3X. They say determine the lengths of the sides of the rectangle using the given area. Give answers exactly and approximately to the nearest tenth. So they want two types of answers. So the problem is the area of the rectangle is 45 square centimeters. So you don't read it 45 centimeters squared, it's 45 square centimeters. And so you're going to write an equation. There are a lot of different ways to do it, but this is an algebra class and you are going to write an equation. So the main thing, the key word is area. So we know from like second grade that area is the length times the width of a rectangle. So if the area is the length times the width, just plug in the information. So they're telling us that the area is 45 centimeters. We know that the length is 3x and the width is x. So you can solve for x. And after you solve for x, you could plug it in to this x to get the length, and you could plug it into that x to get the width. And that's what they want. They want to know what sides are given this information. So you have 3x squared, which means a quadratic. That means you have to use one of the quadratic solving methods. Now, you only know two of them. So we have solved quadratic equations by factoring and square roots. Those are the two most efficient and easiest methods. I have not showed you how to solve by completing the square and the quadratic formula, but that's coming up. All right. So we're going to use square root method. So I think everything's divisible by 3. So that's what I would do is simplify. So x squared is equal to 3 times what is 4 with 1 remaining, 15. So if x squared equals 15, we have to take the square root to find x. So x would be plus or minus radical 15. And this is a real life problem. So negative square root of 15 doesn't make any sense, but you do write it because I don't want you to get in bad habits. So x is the square root of 15. So now to find the length is 3x. So you would plug in square root of 15. That would be your length. Your width is just x, would be square root of 15. So you would write, you would say the width of the rectangle Now remember that it's not sufficient to leave it like that with a real life problem. You have to write something that makes sense to a human being. So you would say the length is 3 radical 15. And remember, they wanted an approximation. So you need to put that on the calculator, or about what? What's 3 times radical 15?
11.6.
11.6 centimeters. And the width is square root of 15, or about, what's square root of 15 on the calculator?
3.9.
3.9 centimeters. So pretty easy. Take a look at page 123, number 21. They're giving you a square with one side being x, which means all the sides are x. And they're giving you a bigger square where one of the sides is 2x, which means all the sides is 2x. So let me read. This is a geometry problem. It says determine the length of the sides of each square using the given information. Give the answers exactly and approximately. And here's the problem. It says the area of the larger square is 42 square centimeters more than the area of the smaller square. Now, what I recommend you do is write something in English and then convert it to math. So let's just decipher this English statement into something that's kind of English math, and then we're going to write the math statement. So basically what it says that the area of the larger square is, in math, means equals. And it says 42 square centimeters more than the area of the smaller one. So 42 square centimeters more than the area of the smaller one. 42 more. So doesn't more mean add 42? And wouldn't this be 42 more than the smaller square? So let's read it again. The area of the larger square is 42 more than the area of the smaller square. So now actually do the math. Well, first of all, the area is equal to the length times the width. And if we were looking at the large square, wouldn't the area be the length times the width, which would be 4x squared? And the area of the small square, wouldn't that also be the length times the width, which is x squared? So now we're going to write the mathematical statement that the area of the larger square is equal to the area of the smaller square plus 42.
Can you move your camera a little bit, please?
So I'm not going to do the problem, but this is how you would set it up. So now you have a quadratic equation. It looks like you can use square roots to do this. So you would subtract x squared, isolate the square, and take the square root of both sides. And then make sure you write your answer as exact answers and approximations. And they are asking for the side of the smaller square, which would be the same all the way around, and the side of the bigger square, which would be the same all the way around. So there's 4 answers, 2 exact answers and 2 approximations. There is another problem like this, so I'm going to set up 22 with you. So number 22 is the same picture, and it says, if the area of the larger square is decreased by 28 square centimeters, the result is half the area of the smaller square. Now, I don't know, I wouldn't try to set this statement up right away. I mean, I would write something that makes sense. So it says, if the area of the larger square is decreased, decrease means subtract. So if the area of the larger square is decreased by 28 square centimeters, the result means equals. The result is half the area of the smaller square. So it's kind of half math, half English, but this says it, right? That if the area of the larger square is decreased by 28 square centimeters, the result is half the area of the smaller square. You guys see that? So once again, you would use the area of the larger square, which is 4x squared. And you would use the area of the smaller square, which is x squared. And now once again, you have a quadratic. How would you do this? Well, this means this, right? So couldn't you multiply everything by 2 and eliminate fractions? So multiply by 2, multiply by 2, and multiply by 2. There. Now, put the x squared on one side, put the numbers on the right side, and use square root method. All right, that is the lesson. It was a very complete and thorough lesson. Make sure you look at your notes if you run into trouble. And what we're going to do today for the rest of the period is we're going to work on the review for the exam. Now, I posted this. I have not posted the key yet. It's there, but I don't want to post it because I don't want you looking at it every 3 seconds. So this is what it looks like. And this is what you're going to do in your Math Wizard teams. And you're actually going to try to complete this. Now, obviously, if you all work separately, it's not going to get done. So you've got to work together to try to complete this review. Okay, like I said, this is an assignment that will be due on October 2nd. But we're going to work on it today in the Math Wizard teams. Okay, now if you can print this out quickly, fine. If not, just write it on a sheet of paper and show your work. All right. I'll be checking in with you. I'll be taking attendance. Does anybody want to ask me any questions about anything on the board?
Ms. Birch, I have a question, but it's not about what's on the board. Do we have to come back to this meeting or no?
We're not coming back.
Oh, okay.
So class is over at 2:10, and I'm gonna give you 1 hour to work on this review. And I'm hoping that if the test looks like this, you can do it in 1 hour. So the test is gonna look very, very similar to this. You got to be able to do this exam, this review in 1 hour.
Ms. Birch,
Yeah.
when you said the test was on Tuesday, do you mean this Tuesday or next Tuesday?
No, not this, not tomorrow.
Okay.
The test is on the 6th.
Okay, thank you.
So let me just go over this. So this lesson 3.1 that I gave you book work, I gave you online work, and I gave you a practice AB. That's due on Thursday night this week. This review that you're going to work right now in groups, in teams, is due this Friday, the 2nd. This exam 3.1 is on October 6th. So that's a week from tomorrow at 8 a.m. Any questions? So just to clarify, we're not going to be spending time on this week on this. I've already spent 2 weeks on this. So yeah. So if you have questions, make sure you ask me today, but I'm going to be teaching new lessons in the future. So, all right, I will see you in the teams. Make sure that you send me a reminder if you need help. Please, please, please work together so we can work this quickly and efficiently. I don't want to come back 30 minutes from now and you're still on problem number 2. Okay? I want you to try to do this in 1 hour. You're trying to complete this as a team in 1 hour. So let me just say some stuff here. If somebody comes in late, they just have to catch up. You know, if somebody their pencil broken or they ran out of lead, they're just going to have to catch up. I don't want any one person dragging the team down. I want this team to work right along through the hour. Okay? I know it sounds harsh, but I'm trying to get you guys to work together and I want the team working along, flowing along. Okay? All right. I'll see you in the teams. Let me know if you need help. Class is over at, 2:10? So 2:10, you will not be reporting back here.
Wait, so Miss Birch, we're allowed to like close this meet and then just go to the Google Meet on the Wizard?
You can close it.
Okay, thank you.
Yeah, you can close this meeting and go to your team meeting because we're not reporting back. And I'll see you in your teams.